Hey everybody. For transformations, we've done translations, reflections, rotations, and now we're going to do dilations. So, to dilate a figure on the coordinate plane, multiply the x and y values of each ordered pair by the given scale factor. Okay. So, describe what should happen if the scale factor is greater than 1. Okay. So a scale factor is basically what you're going to increase every single value by. So like it says, the x and y values. So let's say I stepped into a machine and the scale factor that the machine was set to was 2. That means that every part of my body would get bigger by 2 times, right? So my arms would be 2 times as long, my legs, well, my head, my torso, and everything, okay? So when the scale factor is greater than 1, the image will be enlarged / bigger. Okay. And for the opposite, if it's less than 1, then the image will get reduced. Okay, / smaller. Okay. So when dilation has occurred on the coordinate plane, you can find the scale factor by choosing corresponding sides or vertices and setting up a ratio. Another word for ratio is a fraction, right? So you can either find it by doing the pre-image divided by the original, or the original divided by the pre-image. But a little saying that I like to use whenever I'm trying to find the scale factor between 2 images is no. Okay, what I mean by that is NO, new, over old. Okay, so you're going to take the new image's points and divide it by the old image, and that'll give you your scale factor. And I'll explain that later on. So dilate the rectangle shown by a scale factor of 1/3. So let's go ahead and label these points. We got A, B, C, and D. Okay, so my scale factor is 1/3, right? 1/3 in decimal form is 0.333. Okay, so since that's less than 1, I know that it's going to be a reduction. I know that my rectangle is going to get smaller. Okay, so A is going to be at -6 and 3. B is at 6 and 3. C is at 6 and -3, and then -6 and -3. Okay, so now to find my new image's points, I'm going to take my scale factor and multiply it by my x and y values, right? Okay. So I'm going to take 0.333 and multiply it by -6. Okay, and when you round up, that'll get you a -2. 3 times 0.333 is going to get you +1. Okay, so that's A prime. All right, 6 will get you, let's see, 6 again will get you 2 and 1. That's B prime. 6 will get you 2, and then -3 would be -1. That's C prime. D is going to be -2 and -1. So let's go ahead and plot these points. We've got -2 and 1, +2 and 1, +2 and -1, and then -2 and -1. Okay. So these are new points. A prime, B prime, C prime, and D prime. Okay. So now I know that this this rectangle is 1/3 the size of this bigger rectangle because that's how much we shrunk it with our scale factor. Okay. So how can we represent this algebraically? Well, we always start an algebraic representation with x and y in parentheses. This arrow means a transformation is happening. So how do we go from -6 to -2? Well, we multiply by our scale factor, right, which was 1/3. Okay, we multiply both the x and y by 1/3. Okay. So compare the ratios of the corresponding sides. What do you notice? Well, let's take A, for instance, and A prime. The x value for A was -6, and the y was 3. Okay. Well, I know that I can simplify negative 6 over 3. Okay, negative 6 divided by 3 would be negative 2. The x for a prime was negative 2, and the y value was 1. Okay. So what's negative 2 divided by 1? Well, any number divided by 1 is the number itself, so that would be negative 2. Okay. What do we notice? They have the same ratio. Okay. All right. Did the dilation change or preserve the orientation of the figure and the orientation of the vertices? No, it does not. But the images, okay, are no longer congruent. Congruent kind of means same. All right. So I want y'all to pause the video right here, and I want y'all to try question 4 for yourself. Okay, but I'm gonna go ahead and write these answers then. Okay. So we got E, F, G, and H. E is at negative 4, comma 2. F is at 4, 2. G is at 3 and negative 1, and H is at negative 3. So now I'm going to take my scale factor, which is 2. Okay, my scale factor is greater than 1, so I know that this image is going to be enlarged, right? Negative 2 times 4 is negative 8. Negative 2 times 2 is 4. Okay, and I'm going to do this for the rest of the points as well. So 4 times 2 is 8, and then 2 times 2 is 4. 3 times 2 is 6. Negative 1 times 2 is negative 2. Negative 3 times 2 is negative 6. And negative 1 times 2 is negative 2. All right? So let's go ahead and plot these points. I got my E prime, which is now negative 8 and 4. Right here. E prime. F prime is at 8, 4 all the way over here. Prime. G is at 6, negative 2, down here. That's G prime. And then H prime is at negative 6 and negative 2. Okay? That is G prime. So my new image is going to look like this, right? Okay. So basically, I just made this shape 2 times bigger, okay? And I know it's 2 times bigger because that's what I applied my scale factor with. It was a scale factor of 2. So my algebraic representation is going to be x, y, arrow, my scale factor, which is 2, my x value, and same thing for y. Okay. So again, for question 5, I want you to pause the video and try for yourself, but I'm going to go ahead right now and put in the points. So I got I, J, and K. I is at 0, 4. J is at 4, negative 2. Okay. K is at negative 4, negative 2. Right, so my scale factor now is 3 over 2. So 3 over 2 in decimal form is going to be 1.5. 1.5 is greater than 1, so I know that this triangle is going to be expanded. Okay? It's going to be 1.5 times bigger than this original triangle. So any number multiplied by 0 will be 0. Okay? 4 times 1.5, which is my scale factor, will be 6. 4 again times 1.5 will be 6. Negative 2 times 1.5 will get you negative 3. And then K, negative 4 times 1.5 is negative 6 this time. And negative 2 times 1.5 is negative 3. Okay? So let's go ahead and plot these new points. I got I prime, which is at 0 and 6. I prime. J prime is at 6, negative 3. So 6 and negative 3. That's J prime. K is at negative 6, negative 3. So K prime. So let's go ahead and connect these dots. Okay. So, well, our new triangle is now definitely bigger than our old one, and it's bigger by a scale factor of 1.5. Okay. So my algebraic representation is going to always start out as x, y, always, always, always. Then you draw the arrow, so a transformation happened. And then what happened? What's our scale factor? Our scale factor is 3 over 2, or 1.5. And we applied that to both our x and our y values, right? Because we took our 0 and we multiplied it by 1.5, and it stays 0. We took our y value 4 and multiplied it by 1.5 to get 6. Okay, that's what we did for all of these. So question 6 right here is asking, find the scale factor that was used in the dilation, right? So now they already applied the scale factor to the old image and made a new one, right? So let's take point M for instance, okay? M in the pre-image is at 4 and 4. So 4, 4, okay? Well, M prime is at 5, 5, right? 5, 5. So let's scroll all the way back up here real quick, and let's look at our notes. So, again, when you're trying to find the scale factor, you're going to do this right here, new over old, okay? New divided by old. So let's take our new point, in this case, our new point M, all right? So M prime was at 5, 5. All right, and then M was at what? M was at 4, 4. Okay, this is the new M at 5, 5, and the old M is at 4, 4. So now we're just going to divide. 5 divided by 4 is, okay, you can put it in decimal form or you can leave it like this. So the scale factor, we'll write SF equals, scale factor is either 5, 4, 5 divided by 4, or we can do 1.25. Okay, so I want you to go ahead and try that for question 7. All right, pause the video. Okay, the scale factor for question 7, let's take a look at R. New R prime is at 3 and 1. So 3, 1. Let's divide that by its old, okay? Our old scale factor, or old point R, was at 9 and 3. 9, 3. Okay? So, in question 6, they were both the same numbers, which is convenient, but over here it's a little bit different, right? 3 divided by 9 is, well, I know I can simplify that to, if I bring that down, that would be 1 over 3. Can I simplify 1 over 3 any further? No, right? So, since they're both 1 over 3, we know that it's proportional. Okay, so the scale factor must be 1 over 3. So, scale factor equals 1 over 3. Okay. So, I want you to go ahead and try and solve questions 8, 9, and 10 on your own. All right? Okay, pause the video and try it for yourself. I'm going to go ahead and solve these. Okay, so the scale factor here, we go from 9 to 6, so it's a reduction, right? So it has to be less than, what? Less than 1, right? Let's go take our new, let's use the x values for instance. We do 6 over 9. This is our, we do 6 over 9 because we're doing new over old. Okay, 6 over 9, I know I can simplify into 2 over 3. Okay, over here, let's do the y value this time. Y value in the new one is negative 18 over negative 15. This equals new over old. Okay, negative 18 divided by negative 15. I know I can simplify that because 3 can fit into both of them an equal amount of times. So 3 goes into negative 18 6 times, and it stays a negative. And then it goes into 15 5 times. So this is your scale factor for 9. And last but not least, let's do the x value for question 10. Let's take the new x value for u. U prime was at negative 9. We're dividing it by negative 1. because that's the old x value for the old u, like the pre-image u. Negative 9 divided by negative 1, the negatives will cancel out, right? So that means it's going to be, the scale factor is going to be